Right. Thank you for the introduction, Juraj. So yeah, perhaps you have seen the tweet for Robin Frischman yesterday, how much he was burning calories, shaking. So I definitely need one of those smartwatches now to beat him. Right. So I'm Juraj, and I'm coming from Vacuum Labs. Short promo. In Vacuum Labs, we have over 120 people based in Bratislava, and also offices in 4 other cities, including Prague. So we are interested in crypto, fintech, web native, or backend development. If you're interested, just grab us, and we'll talk. Okay. So now for the reduced Redux. First, what it is. I'll ask this question. How many of you here had the honor to code at least a very simple example in Redux? Come on, all your hands up, right? Yeah, everybody is. Many of you have done Redux, so you probably know what I'm talking about. First, very briefly, what's Redux about? For those who don't know, you have a state, a Redux state, which renders the UI via some components. The user interacts with the UI, triggering some actions, and then the actions get called by a reducer. And the reducer updates the state accordingly. Every time the state is updated, the UI gets re-rendered, and we have this nice unidirectional data flow. It's good because it ensures consistency, it makes it easy to reason about. We also get this Redux logger, which tells you the previous state, the next state, the action that happened, and it makes debugging quite easy and simple. I really think it's a great idea, but there are a couple of issues for those who have gone through this. But to illustrate that, let's first create the simple counter in a big project. So what would you do? You would first need to create some unique type somewhere. Perhaps you put it in types.js. So you create some string that has to be unique for this action. Then you create actions and reducers. So in actions, you put the action creator, which takes some arguments, puts in the payload, and the type. I hope this. Oh, I managed to fix the bezels. OK, great. You put in the type and payload, and then you import this type again in the reducers. We actually write the logic that should be happening, that you want to increase this simple counter by 1 or by some amount, right? So what's the problem here? There's a lot of code to write to just update a very simple value in the state. Many of you, I guess, many of you have gone through this frustration. Well, just to ask, how many of you have gone through this verbosity of Redux and eventually went to search for something else, something that would reduce the boilerplate in Redux? Right. So I would say we are quite lazy programmers, right? We don't want to write a lot of code just to achieve a very simple thing. We just want to write the least to achieve the most. So you might think that this is just another attempt. Yeah, there are plenty of attempts to reduce the boilerplate. But when you search for something like this, you find libraries which invent some syntactic sugar over that. So they just invent syntactic sugar over how to create actions or how to register the reducers, but the traffic there stays the same. They're still dispatching the same actions with type and payload, and they are afraid to do fundamental changes to Redux. So let's do that here. First, what's the problem here? We gotta dispatch things which are then listened to and matched against the reducer. And that's why it means so much code, because we always write the publishing and the subscriber part for every action, regardless of how simple it looks like. Well, most of the time, we need just one subscriber per one publisher, because we know what we want to do with the state, how do we want to update it. So what can we do with this? How can we make this less scattered through the code? How can we put the logic in one place so that when I look at it, I don't have to go through several files to figure out what's actually happening? How do we stop this mental challenge that you have to go through every time you're creating action? Mental challenge of creating a unique string, thinking that, oh, if this has ever been used before, or how should I scope it? Right, so imagine a suspensive drum roll here. Let's dispatch the reducer. Like, what? What is this guy talking about, right? So we're not dispatching reducer, we're dispatching actions, and they're meshed against reducers. No, what? No. Let's stay with me on this, okay? So this is how a regular action would look like. We are dispatching some objects which contain type and payload. But essentially, they're just objects, right? So they can contain anything. So let's make them contain a reducer. Yeah, figure that one out as well. This is empty space here, so you don't have to worry about the comments there. So if we dispatch a reducer here, we tell exactly what should be happening. Now, what are the properties of this? By the way, the update there, there's an immutability helper update, which just gets the some structure of the object and the state, which I forgot to write there, but should be at the bottom, and update the state immutably. Right, so what properties does this have? Since we are dispatching exactly the reducer that should happen, we don't need the type anymore. There is nothing to match the action against. So we could just simply dispose of the type, but we still keep it because Redux tools, they expect the type to be there, and it's useful for logging. So it's useful for knowing which action was actually dispatched. But it's no longer required to be unique. All right, so the reducer here still looks very verbose, right? So I'm just updating some value in state, but I have to write all of that code. So most of the time, you have a couple of actions which are related to the same part, which are related to the same module. And they share some similarities, such as the path where they're updating the state. So we could simply just extract this path, and instead of having the reducer operate on the whole state, we'd make the reducer operate on just some substate on the given path. So now the reducer will be responsible for updating the state on the given path and returning a new state which should be on the given path, right? So yeah, this is basically all that is about. We could, as well as we have these modules related to some specific path, we could just extract it to variable just to avoid some typos, and that's it. So, but the nice thing is, that's all the code you need to write to just create some action, right? You might think, we also did some fundamental changes to Redux, so we just cannot use the former root reducer. We'll need to do some changes to the root reducer as well. But as all of the logic is now specified in the action itself, the root reducer will essentially be very dumb. It doesn't have to do pretty much anything. It just takes the action, passes the reducer, the substate on the given path, and updates the substate on the given path. That's it, because all the logic is in the dispatched action. Now, what is this about? What we gained? Let's recap a little. OK, so we have logic in one place. This didn't go very well. Oh, we have logic in one place, which is very useful for debugging. Now imagine that in standard Redux, you debug like, you go to your log, you see the action that has been dispatched, you search for the string, you find it in types, you find the constant, you look for the constant, you find it in the reducer, a couple of reducers, and then someone has renamed the parameters in payload in the action creator, right? Well, good luck debugging then. Now, you only look for a type, and you go to this one place and see what's happening. This is the reducer that changes state. This is what happened to state. The reducer is the what, then the path is the where. Now, I want to find out what this action is doing. It's simple. Go to definition of this action creator. In traditional Redux, I would go to definition of the action creator. I'll find out that there's some type. So let's search for this type and search for the reducers. Finally, find out what state changes will happen when I call this. OK. Additionally, there are no more unique types. I don't have to go through this mental challenge of thinking, yeah, this is update form. Update form already exists. So let's scope it user settings/update form. Hope this one doesn't exist. No more challenge like this. So we don't have to invent unique types anymore. But still, if you want to preserve unique types, which might be nice, you can. But nobody forces you to. There is inherently less code altogether. That's because this is really all the code you need to write to change something in the state. So you only write the least possible code because the reducers specify what you want to do, and the path is where you want to do it. There is no less than that. So you specify the least to achieve the most. We also get something like, Redux component reusability, which, what I call it, it's something like, imagine you have a Redux component with all of its actions and selectors related to some its subpath where it's mounted, and you want to display it somewhere else, but with its own state. Well, the path is now dynamic, so you could abstract it and make the component relative to some dynamic path. This is quite hard to achieve with traditional Redux, and it's quite a powerful concept. Just take a moment to process this. This is all the code you need to write, okay? There's no more verbosity or frustration. We are using this approach in production in many projects already, in mid to large scale projects. And I'm very glad we are. I'm happy with it. So you're free to try it out. You can also do the very same things with this Redux as with the traditional, the standard one, but just with less code and less scattered. You can achieve the very same. Now, I get this question a lot, so perhaps it's on the Slido, I don't know. Most of the time you have, I said that most of the time you have one subscriber for one publisher. So you mostly do just changes in one part of the state for every action. But what if you want to do updates in multiple parts of the state at the very same time? What if you had more subscribers? So how would that work? Now we only have one reducer here, right? So what can we do with that? To imagine this situation, just imagine you have a logout action. So you first call API for logout, and then you could just, you want to probably clear several parts of the state. You could go and dispatch it one by one, but as the dispatch is synchronous, this would cause you having intermediate states, and all of the map state to probs in connect, they would recompute. So you might have glitches, intermediate state, you want to avoid that. You want to avoid such inconsistency like this. So what do? In standard Redux, you would just define an action creator, and you would listen to it in multiple places. This would be in single state transition. So we'd like to achieve something like this with this reduced Redux. We'd like to go from something like that, having 3 dispatches or multiple dispatches, into a single one, perhaps dispatching an array of actions, which would happen at the very same time, which would happen in the one state transition. So how can we make it basically a single action? Any guesses? Oh, so that's with middlewares and functional composition. So first, now we have to realize that we are dispatching a reducer. And the reducer is really just a function that takes a state and returns a new state. So we could just compose them together. We could just pass the state to the first one, see what it has returned, pass the state to the next one, and so on. So that's how we could compose the reducers. And we'll use middlewares to transform the array that we dispatch into an action with these composed reducers. So let's see how would that work. This is some standard Redux middleware syntax. So here we would do all the magic. This catches the actions. And first, we have to detect if it's an array. If it's an array of actions, we'll compose it to a single action. If it's not, we simply pass it to the next middleware. Now, this is how the magic happens here. We need to create an action, so we need to give it some type. I went with batch dispatch, but you're free to name it whatever you want. Also, I dispatched these actions here just for the logging purposes, so that I know what has been dispatched. And the magic here happens in the reducer, and we compose it exactly as I said before. Now, this slide, let's suppose that the reducers always take the whole state, not some local state with the path, but just the whole state. So we'll simply just compose them all together. Take the state, apply the first reducer, take what it has returned, apply the next reducer, and so on. And then dispatch this action. But we've simplified the actions so that they contain path and reducers, and the reducers would operate on some substate on the given path. So we'll make this big action operate on a global path, and create a reducer that operates on the whole state from this local reducer and path. So it's possible it's what this simple function does there. And this is all the code you need to write. Is it? Yeah, this is all the code you need to write for creating such middleware, and you can now simply dispatch multiple actions which happen at the very same time in the single state transition. So I can now go and update my logout action like this and dispatch these multiple actions within a single state transition. So yeah, this is reused Redux. That's all it is. We're dispatching reducers in the path where they happen, and we are very happy that we are using it. I no longer want to return to traditional Redux. I don't want to write a lot of code. No, I'm not a verbose kind of guy. But I mentioned a lot of pros, but perhaps you've noticed some cons as well. So we are losing one thing with this approach. You might think we are losing serializability. Now, what's the answer to that? So we can't make this serializable. We can't make the function serializable. So this wouldn't work. The simple answer is that, well, don't use reduced Redux if you want your your actions desperately to be serializable. But now, really, let's be honest here. How many of you do really need serializability desperately in your code in production? How many have used the remote debugging tool in some production code? As I've guessed, there are a couple of hands here. Well, congratulations to you. I'm really glad you did. But most of the time, for most people, you don't need it. You can still log all of the actions that have happened and see what's been happening with the application. But if you still need serializability, we have been experimenting a little, but just keep in mind this is just a theoretical experiment, so we're not using it as in production. We are just thinking about the improvements. So we can't dispatch the reducer anymore, and we'll probably need some piece in code which would match the dispatched actions against some reducers in code, against some functions in code. So essentially, we are bringing back the type. But we'll move things around. So we'll still like the idea of mounting a reducer on some path. So we'll move it to some reducer definition. And we want to preserve one-to-one correspondence between the actions and the reducers. So instead of having this type which we write somewhere on import, we don't need that. We can just simply import the type of the reducer in the action creator. Now, we also need to tell the root reducer how the reducer looks like. So the root reducer needs to be aware of all the other reducers. So we'll create some function like register reducer, and which does that for us. And it can also scope the types. It could also make them unique, so you don't have to go through this mental challenge every time. Now, if you look at the action creator here, it looks pretty useless because it doesn't do anything. It just takes the one type, where it's one-to-one correspondence between the reducer, and puts the count in the object, right? So perhaps we don't need it at all, but we're thinking. Let's look how the component where used will look like. So you have this connect here with the map dispatch to props. You bind your action creators, where the change counter binds your action creator, and the increase counter and decrease counter is what you bind. Now, if we didn't have them, if we just didn't have the action creators at all, we'll just simply spread it into a map where the positional arguments of the change counter by function will change to named arguments, and instead of specifying the function, we specify the type, which is not much of an overhead, and we also get named parameters, which might not be a bad thing, right? So yeah, that's it. And still, you need to write very less code for creating some action. This is all you need to write, registering a reducer like this, and you need to call it in the connect like that. So it still preserves the logic in one place. It's still very less code to write. It might not be that bad. But still, we haven't used it in production yet, so it's just a theoretical experiment. Now, you might think that you already have an application which has, in Redux, in traditional Redux, or whatever library you were using for reducing the boilerplate, and it has a lot of actions and a lot of reducers. You don't want to do this in a single transition. It's not worth changing all the actions and reducers in a single pull request. Well, I completely agree with you. It's not worth doing it in a single pull request, right? But you can do it completely gradually. Because you just, these reducers, these different types of reducers, they can very easily coexist with each other. You just have to let everyone have the steering wheel for a while. So you pass the state to an action to the first one, see what it has returned, pass the state to the next one, and so on. So each one gets a say in what happens to the state. And they can easily coexist with each other. There are no issues. Right, so this probably won't work, right? So that's why I went with this approach. OK, so I've prepared a repository with all of these features, all of these different approaches coded. So there is the reduced Redux, the reduced serializable Redux, batched actions middleware for these both approaches, Redux component reusability, which I've mentioned, everything is included there, all coexisting in the same environment. So if you're interested in how that would look like, just go and leave me comments if you find something. If you've run into some issues, I'll be happy to discuss. So I guess that's all from me. And if you have any questions, well, thank you. No, so this will be blind questions.
Can you remember the questions? OK, now. So thanks, Juraj. So I think we have a couple of minutes. We can take some of these questions. Go. And I mean, thanks for the approach of trying to help when using Redux. Is a little bit not so common that people from different companies and teams, they try to share this these explorations. So thank you for that. And let's see the first one. So doesn't coupling the action type with a reducer break its reusability? For example, if we want to use it within Redux Saga.
Right. So I personally didn't have too much experience with Redux Saga, but I didn't like to use it because it adds an additional state to your application. In addition to your state that you have with Redux or other states you still have the state of the Saga where the cursor is. So I didn't like to use it, so I'm not sure how I would really address this question. Sorry, perhaps I studied a bit more about Redux Saga then.
No problem. The next question. So what will happen if we have one reducer taking different actions or multiple actions? How that would be approached?
Yeah, I think this was basically what the batch dispatch middleware was about. So you're saying that you would like to listen to multiple actions. Sorry, you listen to multiple actions? I'm not sure. I could listen to multiple actions using one reducer.
So I guess this will be opposite. So someone asked this question, it should be one action
Listening to, yeah, that's in multiple reducers. If you listen to one action, okay. So this is what the batch dispatch middleware was about. So if you want to do state changes in multiple parts of the state, you just dispatch them as an array of actions in the and the middleware will do its thing. And it's nice because you can also always just check what every action is doing, and you see what you're dispatching. You don't have to go and search for the type and go through all of the reducer that you're handling it. So it's much better, actually.
Okay, let's just take another one. Aren't you recreating reducer function redundantly each time an action is created?
Yes, I am. And I am creating an anonymous function. Well, I am. What are the? I mean, are we going for WebGL performance somewhere or something? This doesn't really matter too much. Creating one anonymous function for every dispatch doesn't really matter. I guess, I would say.
So there are not really great implications from doing that.
Sorry?
There's no big implications like performance-wise or maybe resources.
Well, creating an anonymous function is some performance overhead, but I think it's not too much for dispatch, right? So there is a lot of other overhead happening in dispatch than this.
Okay, I think, yeah, we still have a couple of minutes more. What about testing? Since you keep the reducer inside the action, I think you lose some possibility to test it on its own, like a separate test for that reducer.
That's an interesting question. It really is. So you could still test. Well, I really like to back to the other questions. You could still not make it an anonymous function. You can create some reducers which you test, independently, and then just use them as the functions you have defined in the reducer that you dispatched. So you could do it. That's a good question, really.
Okay, awesome. So let's see. Yeah, I think we have. Okay, let's take the last one now. Isn't dispatching multiple actions an anti-pattern? Wouldn't it be better to have an action for actual user system actions, just to do that?
Dispatching multiple actions as in updating the state and multiple paths at the same time, I don't think this is an anti-pattern. For example, in the logout action, you probably want to do that because you don't want any intermediate states and glitches. And when you're, for example, fetching some data, you probably want to store them in some cache and then store them what you want to display. So I don't think this is really an anti-pattern, dispatching multiple actions. And I don't think I understand the other question.
It will be anti-pattern if you dispatch them separately. But if you dispatch them together, like...
Yeah, if you dispatch them separately, you might have intermediate states. Like, yeah, that would be an anti-pattern. But that's why you can batch the actions.
Well, there's so much to talk about Redux and this new approach. So if you have more questions, yeah. I think I'll be
available at the Vacuum Lab stand. So after this talk, so grab me and let's talk. Okay,
yeah,
thank you.
That's great. Thanks again.